Hey, Bell. All right, so sorry about the glitch the other day. But general idea behind what was happening in the physical end of the lab is the first part of what we're doing is we're trying to, like I said in the pre-lab, build that Beers-Lambert plot. So what we're going to do is we're going to use 5 of our test tubes, and we're going to set up a series of solutions that we know the molarity of. All right, so in the packet, if you look on page 3, underneath number 2, they are giving us our dilutions. They're telling us how much of the 0.200 molar FeNO32 to mix with how much of the 0.0002 molar FeSCN. Now, they don't give us what those molarities are. They show you right underneath question number 2 that you do an M1V1 equals M2V2. So if you do what they show you on the bottom there, and they have shown this for you for the very first one, the 0.200 molar, all right, and the 2 mils, 8 and 2. Those numbers go in this top table under your molarity of these guys. Okay. Then what we're going to do is we're physically going to prep those solutions, and then I'm going to measure the absorbencies of them. All right. And that's how we create that Beers-Lambert plot, right? Where we get those dots working their way up the graph, and then we can draw the line. And then what we'll do is we'll do some test solutions next. And from that, we'll be able to just get their absorbance and then use that chart to see what was their molarity at that point, which would be hopefully letting us get our equilibrium constant. So kind of the overreaching goal. All right, so the first thing we have to do is we have to prep these dilutions. All right, so what we did to do that was we took this guy here, volumetric pipette, and then we took the pipette bulb. Right, how the pipette bulb works, right, is there's a letter at the top that says A. You squeeze on that, deflate the bulb. All right, that creates a vacuum in here. All right, and now there's a S button here and an E, right? S will let you draw solution up. The E lets you release solution. So we attach that to the top. Okay. And then what we do is we would just go to the middle counter, and we're going to get a small sample of the 0.200 FeNO32 solution. Okay, so I'll go over and do that. Here's this guy. All right, now, when I was working with that guy, you want to be careful not to get it on your hands because that was prepared using nitric acid. All right, so the liquid in there is nitric acid with the iron 3 nitrate. All right, then what I'm going to do is I'm going to measure out each of the amounts they say and put it in these containers. All right, so I'm supposed to get 8, then 7, then 6, then 5, then 4. All right, so I'm going to go ahead and do that. All right, so hopefully so you can see it. Okay, so you always kind of overshoot your line, then work it back down. There's my 8. I'll do the same thing. Overshoot, and then back. There's my 7. There's my 6. Okay. All right. And sometimes you just have to create your vacuum. There's my 5. And then last but not least, There is my 4. Okay. Then what I'd want to do is rinse this guy out so I can use it again for my potassium iocyanate solution. So just doing a little cleaning here. I'm taking that up, and I'm just putting this in the sink right now. Okay. All right, so rinsing out our container. All right, and then I'm going to go get the 0.0002 of the potassium thiocyanate, which is this guy. And then the same drill, but we use 2, 3, 4, 5, and 6 milliliters for this guy. All right, so the 2 is going to go in with the 8 that we did in the first one. All right, and then the 3 in with the 7. So notice we have a 10 milliliter constant for all of the containers. So 2 in this first one. And notice what we're doing here is initiating that reaction we talked about in the pre-lab. So we're creating that iron thiocyanate ion, which is supposed to have that quote unquote blood red color to it. Let me turn it so you can see it a bit. Right, then 5. And then last but not least, I need 6 for the last one. Okay, not quite enough in there, so we're just going to add. Like you said, if it starts lagging, all you do is redepress that bulb. There's my 6. All right. Then what I'm going to do is I'm going to use my stir rod. And gently mix these guys to make sure we've got a nice, even solution. Okay. All right, now if I bring these up nice and close for you. I'm not sure if you can quite see, maybe if I hold it like that, you can see they're progressively getting from lighter to darker, which makes sense because when we do this dilution, we're hoping to create an increase in molarity. Right? So in a perfect world, when I bring it over here and bring you over here, you will see hopefully that our absorbances go up when we do this. Okay, good. Just making sure you can see that. All right, so I'm just setting my colorimeter here to read at the wavelength we want, which is 468. All right, and then live recording. All right, so right there you can see 0.00. Then what we'll do is we'll take our cuvette and I'm going to put a sample of our first solution in there. And we're going to get the absorbancy of it. Okay. And I'm going to fill it as much as I can. I have more in my test tube then will fit in the cuvette. So no big deal. I just leave the extra back there. All right, now I cap this thing, and then everyone had a tissue. All right, Kim wiped, and the whole idea was I want to wipe off my cuvette because I don't want any fingerprints to be blocking the light, because what we're measuring with this is how much light gets blocked. So I want all the light being blocked to be due to the, blood reddish color of the liquid that's inside there. Okay, so now I'm going to put this thing in here. All right, and we're going to go ahead and we're going to get ourselves an absorbance. All right, so if we do that, all right, original reading for your first table there, you're looking at 0.882. All right, so on the top line of your table on page number 6, right, you're going to put your 0.882 here. And like I said, you're going to do an M1V1 equals M2V2 calculation to get your molarity at that point. So you don't record this. This is something you have to calculate. This guy is the 0.882. All right, so we're going to do this for each of the other test solutions. Oh, and hang on, that's your bottom number. All right, whenever I showed you what those were, those got reversed on me. All right, so that's your very bottom one. That's your reference solution 5. All right, so 0.882, you want to put down here rather. All right, in the absorbance for test solution 5. Right, because like I said, whenever I spun that around so you could see the colors, I reversed my order. All right, so now I'm just taking this guy and dumping him out. And giving him a rinse. Dumping that out. And then we're into test solution. All right, number, let's go 4. Let's work our way from the bottom up. Let's get that guy out. All right, so we fill that up. Put that down here. Then put that in there. All right, so now we're looking at test solution number 4. All right, test solution number 4, looking like 0.59. Let that stabilize, 0.599. All right, so number 4 reference solution is 0.559599. And then we'll move on to test solution number 3. Give this guy a rinse. All right. And we're testing sample number 3. Okay, wipe it off your sample. All right, so this is our reference solution number 3. Put this in here. Detect our absorbance. Looks to me like we're getting 0.3. Let that stabilize for you. Sometimes you gotta let it sit. All right. Looks like when I let it sit, we're getting 0.389. All right, so a 0.389 for reference solution number 3. Okay, then moving on. Again, kind of repetitive. Just give it a rinse. Go into reference solution number 2. Getting my cap. And wiping that off. All right, reference solution number 2. Angle there. 0.195 is the most stable number, right? I tend to see. All right, so 0.195 is your reference solution 2. And then last but not least, we're going to go get our reference solution 1. Right, and when I put the reference solution 1 in there, looking like 0.139. Okay, so hopefully you filled all those numbers in. All right, and what you're seeing is we go from being least concentrated to most, and we're going to go from least absorbance to most. This table's going to let you build your Beers-Lambert plot, that graph that we keep talking about where you have the axes, and then down here, you're going to put your molarities that you calculate using your dilutions. Here's your absorbance, point. You can draw your line. That's going to let you take your absorbances that we'll get over here from the test solutions, all right, and translate them into info you need for these. Now listen, these two tables here, these two rows, all right, these, all right, are all explained to you in the pre-lab as well on how you get the molarities of these. All right, so you're getting dilutions for these ones as well. All right, then you'll measure absorbance, all right, over here. So this was the only column that we filled in the lab. The rest of these are calculations. So I know it looks like there's a lot of things to record. A lot of those things end up being math problems you do as part of your pre-lab or post-lab stuff. All right, so what you would do in the next part of the experiment is you go to your test solution tables. All right, and if we do that, a couple differences. This time, we're using a different molarity of the FeNO3. We're using a different molarity of the KSCN. Right, so the idea there is I have created different concentrations, and we want to see, are we going to get the same equilibrium constant, right? Because I'm claiming that when these guys reach equilibrium, no matter where I start them at with molarities, they should end up, if I do products over reactants, right, raised to the power of the coefficients, and do that division, they should always yield me the same number. That's what we're checking for. So in test solution 6, right, I'm using 5 milliliters of the FeNO3 and 1 milliliter of the KSCN, and then 4 milliliters of water. In 7, I used the same amount of FeNO3, but then I used more of the KSCN and less of the water, right? So we use the same FeNO3 for the whole test bank, and then we start manipulating the other one. So every one of these is going to have the same molarity of FeNO3 in it, but it's going to have a different molarity of FCN, all right? And that should manipulate our concentrations, and then we have to see, is the K value going to be the same? All right, so we would prep those exactly like I just showed you these guys. So I'm not going to walk you through that. I can simply tell you what our absorbances were from that, but you would have just done the same exact thing. You go get a beaker, transfer it, fill up each one, then get the second substance, fill up each one, fill up each one with the distilled water. Notice again, constant volume of 10 milliliters. So your V2 for your dilution problems, your M1 V1s equal M2 V2s, that's going to be 10 milliliters all day long for everything. Right. Put all those in. You're going to notice they're not quite as dark this time. All right. But now I'm going to go get you what those molarities are to fill in that table. All right, so if I bring you up here, give you some numbers for your test solutions. Okay. All right, so for your test solution, it's number 6. All right, so for test solution 6, your absorbance right here, all right, that is going to be 0.128. For test solution 7, 0.218. Test solution 8, 0.322. Test solution 9, 0.428. And then test solution 10, 0.538. All right, so I'm going to jot those in there just so you can double check, did you copy them correctly? All right, so that is what those values should be. And like I said, for the other 2 columns in this table, right, if you look back into your pre-lab, right, number 3 of your pre-lab, right, is showing you a dilution problem, right, and M1V1 equals M2V2, and that is where all the numbers that are in here come from. All right, so it was, I gave them to you from the colorimeter, pre-lab question number 2. I gave it to you from the colorimeter, pre-lab questions number 3. All right, when you get down to here, now you're into post-lab questions. You have to create your Beers-Lambert plot, right? You'll get these from your Beers-Lambert plot, and then post-lab questions, I think number 4 and number 5, get you to fill these in. So you'll have all sorts of math on a different page, and you'll end up just transferring it into that results table. All right, so I hope it helped you out. Shoot me an email or Parent Square, whatever. If you have any questions, we can jump on a Google Meet and get you sorted out. Other than that, I hope all is well. See ya.